Throwback song.
Throwback Thursday, the 4th of March. You guys will be able to factor by using the distributive property section 7.1. First thing I'm going to do is write my name on this. Me llamo Senor Castle. My bad, Mrs. Jill Bradney. My bad.
No, that's your fault.
Okay.
I'm gonna call you Mrs. Karen Castle.
You have been.
Yeah.
I've been calling you Hannah.
No, you've been calling you Hannah.
What was her
Yeah, the
maiden
last
name?
2 times maybe. Anyway, so definitions.
How sad.
So here's the definition. Factors. Factors are going to be numbers and or variables that divide evenly into a term. Now before we talk about factors multiplying, like these are the factors of this. Like, for example, don't write this part down, you don't have to. 2 times 3 equals 6. 2 times 3 are 2 and 3 are factors of 6 because they multiply to 6. Now they both also divide evenly into it because they multiply to get it. 2 goes into 6 3 times. Now 3 is an odd number, but we say it still divides it evenly because it doesn't leave a remainder, a decimal, fraction, anything like that. 3 goes into an even number of times because it goes into an integer number of times, a whole integer, not a decimal, fraction, that kind of thing. Yes?
Are we doing greatest common factors?
Yes.
Let's go.
All right, so what are the factors of 72?
I don't know.
8 and what?
9.
9. 8 times 9.
Do we write this down?
Yep, but I want us to write it down in a very specific way. So actually, I'll wait to write this part down. What did you say, 1 and 72?
You said that 2 seconds.
That's true. What did you say? Not 37 times 2, but 2 times
36 and 2.
36 and 2. Very close, very close.
Don't write this part down yet.
What else? There's going to be 3 more pairs we're missing.
What?
You have 3 pairs? That's half.
72 and 1. Oh,
Okay,
12 and
6 and 12.
Yeah.
Very good teamwork there. All right, you get 3 and...
Factors. 70 times 1. 44.
Haha.
72 times 1.
No.
Yep.
Don't be
We have
laughing
that
at
up
Kobe
there.
like
The other way
that.
around.
Oh,
Dog.
we'll count it. We'll count that as both.
Hey, Mr. Karen Castle.
Yes.
Wouldn't 4 be 1?
Yep. 4 is 1.
I don't know what it is.
4 and 30, 28.
No, nobody. 48. No, 18.
4.
100.
All right. Now these are the 6 pairs. I want you to write them down just like I have them here.
Oh, I did this thing.
Oh, okay, that'll work.
Why?
I wrote 27 and not 7.
Ah. 17.
Mr. Castle.
It was 17.
We have an issue.
I said 27. I wrote 1 times 27.
Oh, instead of 72. Oh my bad. I thought you said it says 17.
Mr. Castle,
What's up?
you live.
Yes. I haven't looked in a while though. Ever?
Yeah.
My PR for bench was 275.
That's it? I do that with one arm.
Uh-huh. I believe it.
I bet you did.
I actually do.
Uh-huh. In your dreams, and then you woke up?
Oh.
Now, I went through it this way very specifically because
1, 2,
as we're going
3,
through, it goes in order. 1, 2, 3, 4. Does 5 go into 72? No, so we skip it. 6. Does 7 go into 72? No, so we skip it. 8. Now, notice, as we were to go to 9, we actually say, oh, 9's over here. So
And it
because
goes
we have to
around.
start going to the other side again,
10, 11, 12, 13, 14, 15.
as we start going to the other side again, because that's where 9 is, that means we're done. So once you keep going through these, and you keep going, and you end up getting the other side, you've covered all of them, unless you missed one somewhere by chance, by accident. Bailey, what did you say?
I said, see, I told you it was 72 times 1.
Alright,
Yes.
have you ever noticed this? Look, so if you go from 9 to 12, that's 3. So all these are factors of 3. You go to 12 to 18, that's 6. That's a factor of 3. And then, and then 24, 18, 24, that's a factor of 3. 24 to 36, that's 12. That's a factor of 3. And 36, 72, that's 36.
He is not captain.
Factor
He is
of
not
3.
So
captain.
that is neat that all of those are. That's not necessarily an indicator for us, but that is true that those are in fact times 3. All right. So a prime number. Does anyone know what a prime number is?
Oh.
Okay, Lincoln. Or excuse me, Logan. My goodness, I do it every time.
It's the prime number. Like a prime alpha male.
Okay, Ash.
It's a number whose only factors are 1 and of itself.
Very good. It's a number whose factors are only 1 and itself.
I know 1's 7.
Okay, so 7 would be an example. Raise your hand for another example. Lincoln. 1 is technically not because it says a number greater than 1. So 1 is not greater than 1. Jill. 3. 3 and 1. Yes. 5. 5 and 1. Sarah.
Odd numbers. 11.
Not necessarily. What about 9?
9 is 1.
it has 3.
Is 9 prime?
No.
No, it's not necessarily. But are even numbers prime?
Yeah.
Some.
No.
What about
no.
4?
No, even numbers
6,
are prime.
8,
No.
10. Are any of those prime?
No.
No, but 2 is. 2 is the only prime even number.
11.
Phoenix, what did you say?
13.
13, 11. Okay, now guys, there's actually infinitely many prime numbers. You could go on and on and on forever, and you could actually always find at least one prime number. 73, prime number. Okay.
75.
77 is not because 7 and 11 go into it.
7.
7? 7 is prime, yep. All right, composite numbers, that's the opposite. So it's a number that is not prime. So who can give me raise your hand for an example of a composite number? Lincoln.
6.
6, 3 times 2. Logan.
10.
10, 5 times 2. Mally. Okay. Hayden.
4.
4, 2 times 2. Amy. 8, 2 times 4. Jill. What? 20. 4 times 5, 2 times 10. Yes. Bailey.
Question.
Okay.
It says 0 and 1 are neither prime nor composite.
Yes.
What are they then?
They just aren't in their own category
You
of
didn't
being
say
not
that
this
on
or
the
this. They're not in a specific category.
There?
Yeah, they're just there.
7.
Good question. Good question. Yeah, 0 and prime are neither prime nor composite. What?
They're nothing.
They're just not in one of these categories. So if you were to make a diagram for these, it'd be like here are the prime numbers, here are the composite numbers, and here are 0 and 1. They just be in 3 different categories. They're just in their own little category, saying, neither. Yeah.
1,000.
1,000 is composite. How do we know 1,000 is composite? Okay, 10 goes into it because it ends in a 0. Okay, or 2 goes into it because it ends in a 0. What else goes into it because it ends in a 0? 5 goes into it because it ends in a 0. Okay. So we're going to go over some quick rules or tips to check for if a number goes into another number. So we were just saying, as we went through the factor 72, does this go into it? Does this go into it? Does this go into it? This is a way we can go through and try and find this for, and so these are helpful for what you're just doing. If 2 goes into it, it's an even number. It ends in 0, 2, 4, 6, or 8. So no matter what number you give me, like 1,000, it ends in 0, 2 goes into it. If you give me any number that ends in 2, 2 goes into it. 3. This one is very helpful. This one is one that I always use actually quite a bit. The sum of the digits is divisible by 3. So we just talked about 72. So sum means adding. What's 7 plus 2? 9. Now does 3 go into 9? So 3 goes into 72. What if I gave you guys the number 512? What's 5 plus 1 plus 2?
3, 8.
8. Does 3 go into 8?
No.
No. So does 3 go into 512?
No.
No. What about if I make it 513?
Yes.
Because 5 plus 1 plus 3 is what?
9.
9. Does 3 go into 9?
Yeah.
Yeah. Or if I make it 53. What's 7 plus 5 plus 3?
15.
15. Does 3 go into 15?
C.
Yeah, so does 3 go into 753?
Yeah.
Yes. Now, does this help us know how many times it goes in? No.
The number.
But it just lets us know if it goes in or not. It lets us know if we should even bother trying to divide. Because if we have a number like we said 512 didn't work, we don't want to divide it by 3 and go through all this work and just to find out at the end, oh, it actually doesn't work. That'd be kind of annoying. So instead we can test, hey, does it work? And then we can figure out how many times. 4, this one's somewhat useful part of the time, not useful others. I'll give you another one for when it's not useful for others. The last two digits are divisible by 6. So let's take 16 for example. 16 is divisible by 6, right? Divisible by 4, right? So if I make it 216, are the last two digits still divisible by 4? Yeah, so 216 is. If I make it 5,216, it still is. 35,216 still is. 730, it doesn't matter what numbers I keep adding onto the front. The last two are, so the whole thing is. Yes?
If you look at like the last two as individual or like you look at it as 16.
Great question. You look at the last two as 16. Because 4 doesn't go into 1 or 6, but 4 goes into 16. Yep, great question. All right, so times when it's maybe not as helpful is, let's say we have the number 392. Well, do we know off the top of our head if 4 goes into 92? Okay, probably not. We know 16. Probably don't know 392. So for a number like 92, what I do to make it helpful is I try to divide it by 2, and I see if I can do it again. Because if we divide by 2 twice, it's the same thing as dividing by 4. Let me show you why. If I take 16 divided by 2, I get 8. If I take 8 divided by 2, what do I get? 4. Well, how do I get 4 from 16? Divide by 4. If I can divide by 4 to get from 16 to 4. So when you divide by 2 twice, it's like you divide by 4 because 2 times 2 is 4. Okay? So if I can divide by 2 on this, and it's an even number still, I can still divide it by 2, then it's going to be even. 40, a little higher? 41 would be 82. 46. Now, can I divide 46 by 2? Yes, so because 2 can go into 92 twice, 4 goes into it once. Or 4 goes into it at least once, I should say. Not once. It goes into way more than once. Questions on that? 5? What did you say? 23? Oh, yes, it would be. Yep. 5, the last digit 0 or 5. Is that one familiar to us?
Yeah.
Okay. 6, I really like this one as well. The 3 and the 6 one are probably the ones that I have to remember most often. Because I was like, oh, I knew the 2, I knew the 5, I knew the 10. But the 3 and the 6 one are probably the ones that I utilize the most from learning these. If it's divisible by both 2 and 3, it's divisible by 6. Well, what is 2 times 3? 6. That's why. So as you're going through your list and you say 1, 2, 3, by the time you get to 6, you can just check. Did 2 and 3 go into it? If so, 6 goes into it. Now, what if only one of them went into it?
It's not.
Then the 6 doesn't go into it. Regardless of which one it is, if only one of them, they both have to go into it for 6 to go into it. Because 2 times 3 is 6. And that would work for any numbers that multiply to each other. So like 8 goes into it. Actually, no, that's not true. So that doesn't work for 8. Never mind. That does work for 6. I was saying something different. That doesn't work for 8. For to do the 2 and the 4. I misspoke. 8, honestly, we're going to skip it because it's not that useful. 9, the sum of the the sum of the digits is divisible by 9. Is that pretty similar to the 3 one?
I think so.
Yeah, except for we're just seeing if it's divisible by 9 instead of by 3, by that number. So 72 again. What's 7 plus 2? 9. Is 9 divisible by 9?
Yeah, 8 times 9.
Yeah, so 72 is divisible by 9. Now, what about if I give the number 573? What's 5 plus 7 plus 3? 15. So does 3 go into that number? Yes. Does 9 go into that number, though? No. Does that make more sense or no?
Yes.
Okay. And then 10, if it ends in a 0. So can you check the 3 and the 9, though, at the same time? Yeah, because you already added up the digits. Okay. Little ideas. What's up? 9 is the sum of the digits is divisible by 9. So just like 3, but instead you check with 9. So here on 573, we said the sum of 5, 7, and 3 was 15. Well, 9 doesn't go into 15, so 9 doesn't go into this number. However, 9 does go into, 7 plus 6 plus 5 would be 18. Well, 9 goes into 18, so it goes into 765. Yep. All right, greatest common factor. We talked about this a little bit earlier. Lincoln was asking that question if we're going to talk about this today. Does anyone know what a greatest common factor is? Okay.
The biggest factor that is in it.
Okay. The biggest factor that goes into multiple terms. So biggest comes from the greatest there. So greatest means the biggest one. Common means it's shared between them. So of two different numbers, we would say, oh, this is a common factor. So if I give us the numbers, I don't know, 72 and 48, I think it'd be helpful. And we're trying to figure out the factors of 72 and the factors of 48. Well, we already said the factors of 72 were 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 72, 6 and 12, not 72, and 8 and 9. We said those already. We did that.
Hello.
Hi.
How are you?
I'm doing well. How are you?
I'm doing okay.
Okay. I hope it gets better.
Happy day.
You too. Okay can turn it into good. Okay. So, let's figure out 48. We're going to start off, though, with the same lowest to highest. So what number are we going to start off with 48? 1. 1 always goes into something. Okay, now we're going to check what number? 2. Does 2 go into it? Yeah, because it's even. So how many times? 24. Okay, does 3 go into 48? Well, how do we check?
Add them.
Add 4 and 8. What's 4 plus 8?
12.
12. Does 3 go into 12?
Yeah.
So 3 goes into 48. Now we have to figure out how many times. Okay, it goes into 16. Yep, and you would do that by dividing. Okay. Does 4 go into it? Well, when we went 2, it was an even one, so it's still 4 and 12. Okay. Does 5 go into it? No, so we skip it, and 6 goes into it. Yep, 8 times. Now, how could we tell 6 goes into it?
Because it was divisible by 2 and 3.
Because 2 and 3 both go into it. Very good, very good. Okay. Does 7 go into it? No. And then as we go up to the next number, 8, what do we notice? Are we back on the other side? Yeah, so we're done. We got covered all of them. Now, common factors. There's quite a few we see in common, aren't there? We see the 1 in common. We see the 2 in common. We see the 3 in common. We see the 4, the 6, the 8, the 12, the 24. Do we see any others? So we see a lot of common factors, but which of these is the greatest common factor? 24. Haha. So we'd say the GCF of these two is 24. Does that make more sense?
So we figure out what I remember his common factor is that's alike.
Yep.
That's because they both have.
Yep. So that's greatest is biggest, common is shared. So what's the biggest shared factor? What's the biggest one they both have? They have it in common.
Is this part of our homework?
We'll utilize this in our homework, but there's no specific questions of saying GCF of this and this. But we use that as our first step. Okay, let's quick recap of distributing. Distributing, 3 times 2a is what? 6a. 3 times 4 is plus 12. Standard form already. We're done. 2x times 4x in that next problem. 8x squared. Very good. 2x times 5 plus 10x. Now we're going to learn how to go the opposite direction of these, okay? So to go the opposite direction, we're going to use factoring. So we're going to find the GCF of the terms, what we just practiced, and factor the GCF out of the terms by dividing to undo the multiplication. So when we see 15x plus 9, 3 is going to be our GCF. 3 goes into both 15 and 9. And do they both have x's or just one of them? Just one, so they don't have that in common. Okay? But they both have a 3 in common as a factor, and it's actually going to be the biggest one. So we're going to put, it might be helpful for some of us to write this off to the side, that there's the GCF of 3. Then I'm going to put that 3 outside the parenthesis, because we noticed as we got ready to distribute, there was always something outside the parenthesis, right? And something inside the parenthesis. What's outside the parenthesis is our GCF. Now to figure out what goes inside, this is where we do our division.
5x plus 3.
Okay, it is going to be 5x plus 3. Very good. Now how we get that is we take the first term, 15x, and divide it by our GCF, and we're left with 5x. Plus sign stays plus sign there. And we take the 9 divided by 3, which was 3. You guys were on that. My goodness. Call you Hercules because you were on a roll. Bless my soul. Herc was on a roll. Okay. Now, does anything go into both 5x and 3? No. Okay, so we're done. Now, if something were to, we'd have to keep going. It means there was something bigger we could have done. If we were to distribute this back in, would we get what we started with? Yeah. Okay, that's how we can check our work as well. As we progress, there's certain things you guys might stop doing because you just realize you don't need to for some of you. Now, some of you might still benefit from doing it, in which case I want you to do that. So as we progress, if you don't need to write the GCF off to the side, don't. If it helps you, keep doing it. As we progress, if you don't need to write this division off to the side, don't. If it helps you, keep doing it. Baby, what was your question? No. Okay. So let's look at the second one. 20y minus 35. What's going to be our GCF here, okay? It is 5. Do they have any variables in common? No, so just the 5 is going to be outside the parenthesis. So we could say, hey, we have a GCF of 5. And then as we go to figure out what's inside, we take the 20y, the first term, and divide it by 5. Now what's 20y divided by 5? 4y. The y is still there. Minus now, because it's the minus sign. And we're going to take the 35 divided by 5. And we get 7. Now, do 4y and 7 have anything in common? No. And if we distribute, do we get the same thing as what we started with? Yes, then we did it correctly. Phoenix, what's up? Sorry, Lincoln, what's up? I saw the corner by the wrong person.
What if they did have like something in common in the 4y and 7?
Oh, man, great question. So on number 3, Lincoln was just asking, hey, Mr. Cross, what if they do have like a variable in common? Well, on number 3, do they both have x's? Yeah. Okay. Now, a good way for us to look at this to figure out how many x's they have in common, it might be to write it this way. 12x squared is really 12xx. X times x, right? Plus 3x. So how many x's do they both have? They both have 1. They have 1 in common. So our,
The outside number has an x.
which means the outside number will have an x. So it'll be a what x?
3x.
3x. So our GCF here is a 3x. We're going to finish this one after lunch. Yep. So now we take 12x squared divided by 3x. It'll be 4x. Because you do 12 divided by 3 is 4. X squared divided by x, you subtract. 2 minus 1 is 1. Now,
you don't want to do this. You don't want to do 4 squared then that'd be 12x.
yeah, and another good way to think about that is if you put 4x squared here, when you distribute back in to check your work, you get cubed, and that's not right. And then 3x divided by itself is just 1. So it becomes a plus 1. Now, do 4x and 1 have anything in common? No.
What if that, you ask that, and then what did they actually do at the end?
Then we would go through. I'll actually show that in a bit. What to do? Yeah, great question. Now here as well, another way we can think about it with these x's. X to the first, x to the first. What's 1 minus 1? 0. So there's no x's. Anything to the power of 0 is just 1, right? Okay. Questions on number 3. All right, let's look at number 4 here. Okay. So on number 4, or excuse me, back on number 3, I want to talk about this real quick. So another way to think about it is they both have at least a power of 1 for the x, right? This one has an x to the first, this one x to the 2, x to the second, excuse me. So they both have at least a power of 1. So we were able to take out a power of 1. We take out the smallest power that they both had. So on number 4, what do we think our GCF might be? Well, let's go through part by part. Number-wise, 9 and 15, what do they have in common? 3. Now, x's, how many x's do they have in common? 1, an x to the first. This one has x squared. This one has an x to the first. 1 is the smallest exponent for x we see. What about y's? 1. We see a 1 and a 2 for exponents. Well, the 1's invisible, but we have a 1 and a 2 for exponents, so the 1's smaller. So we take the smallest one, the one that they all at least have. So that's going to be our GCF. 3, let me rewrite this, 3, xy. Now, if I take 9, x squared y, and divide it by 3xy, what's 9 divided by 3? Part by part here? 3. What's x squared divided by x? There's x, 2 minus 1 is 1. What's y divided by y? Just a normal 1. So do I have to write a 1 at the end there? No. So it's 3x minus, let me do the next one. 15xy squared divided by 3xy. Can anyone tell me what this leaves us with? 5y. Now, do 3x and 5y have anything in common? No. If we were to distribute back in, would we get what we started with? Yes, then we did it correctly and we're done. Now, these two questions I'm asking you every time, could you ask yourself those questions on a test? You definitely could, okay? And could that help you maybe even get more points on your test? Yeah, probably could. Wait. Hey, thanks.
Oh, thank you, Mr. Karen.
Oh, sorry.
Still
Oh.
on. It's Hannah.
All right.
I can call whatever I want.
Oh.
That's not true. That's not true. Okay.
What's your
All right.
dad?
I never called him dad, though.
My dad is a wedding and event decorator.
I said your kid.
Oh, what's his name?
Yeah.
Oh, that's probably a different question. Sorry, Terry.
Did he decorate?
It's
Oh,
Terry.
Terry. Just like your dad.
You're cool.
Yeah.
Yeah.
Yes.
Did he decorate your wedding?
Yeah.
Yeah, Kian.
Did you pay him?
No.
Oh, Mr. Coffin.
Family discount.
That's rude.
That's
It's the family, yeah.
I guess it was just...
yeah.
You guys, oh.
Yo.
Mr. Costo.
There is a family discount, I'm not gonna lie.
Mr. Costo.
Yeah.
I feel like you would work at Victoria's
It's
Secret.
so bad. What?
No.
Wait, what did you say? You would be a bouncer to a club.
Stay fierce. Rawr. Be outside the club. Rawr. Rawr. Rawr.
Hi, Tristan.
Rawr. Okay. On 5 here. What do we think our greatest common factor is going to be? 20. Now I'll show you what would have happened if we done 10. No, don't laugh, okay? So 20. And what about our variables? What about x's? X squared. Yeah, the lowest one we see is 2. We see a 4 and a 2. What about y's? Y is to the second. 2 of them. Because we see a y squared and a y to the third. They both have at least a 2. A 2 and a 3. The smallest is 2. So we're able to take all of that out. Now, we might be able to start doing these things where we don't even have to write it off to the side. Now, if you're still more comfortable writing the division off to the side, please do it. But if you're at the point you're like, Mr. House, I don't want to write it off side. Well, don't. Okay? As long as it won't make you get more wrong, I'm fine with that. So, what would we be left with after 40x to the 4th y squared and we factor out this 20x squared y squared? 2 x squared. Anything with y? No. No, y to the power of 0, which is nothing. Plus,
But don't you just have to what?
not on this first one. Just y. Now, see, the reason why you don't have to put that y on that first one is because you had squared and you took both of them away. So you don't have any of them left. Whereas on the second one, you took 2 of them away, you're still left with 1. Does that make more sense? All right, great question. Rawr. Yep, you'd be fine. Yep. Now, do 2x squared and y have anything in common? Nope. And if we distribute, do we get the same thing? That's what we started with. Yeah, that means we're done. Now, here's where I'm going to bring up that question Lincoln was asking, that what if? What if we went with 10? What if we saw 10 was our GCF, and we thought it was, maybe it's a 10x squared y squared. Don't write this part down, okay? What if we thought it was a 10x squared y squared? Well, we'd be left with 4x squared plus 2y. You guys agree 40 divided by 10 is 4, 20 divided by 10 is 2, okay? But 2 can go into both 4 and 2. Now, let me ask this. What was secretly in front of this parenthesis, if I put a parenthesis around this? What's secretly in front of this?
1.
A 1. So as we pulled the 20 x squared y squared out, we just multiplied it with the 1. So what am I going to do as I pull out a 2? Let me say that again. So there's secretly a 1 to start in front of everything, right? Always secretly a 1. So I can say there's secretly a 1 in front of this whole thing. Now, if you were to distribute the 1 in, would it change anything? No, which is why we don't write it. So when I took the 20 x squared y squared and put it out in the front, I multiplied that with 1, which is why you just kept it the same. So here, as we notice, these have a 2 in common, and I pull that out. What am I going to do with this 2 and this 10x squared y squared? What operation am I going to do there? Let's write that down. That's good. We're going to multiply them just like we would have with 1 and 20. We didn't even realize we were doing it, but we actually were. So we'd have to multiply that, and we'd end up with 2 times 10, 20 x squared y squared, and we divide each of those inside the parentheses by 2, and we end up with 2x squared y. Do we get the same thing either way? Yeah, we super do. So does it necessarily matter which way you go through it? No. Do we think one of those might be easier than the other? Yeah, the first one, okay? So, kind of the lesson from this is analyze what's going on. Does anyone know what analyze means?
Look at it.
Okay, look at it, and what else?
Think about it.
Think about it, examine it, okay? So take mental notes or actual notes about something, okay? And think about, hey, what is going on here? What are the properties of this? All these things. So analyze it for a moment and think, what is my actual GCF? What is the biggest one? So go through 10. Oh, is there one bigger though? Okay. 20. Oh, that saved us so much time and steps. Whereas here, if we went with 10, we had to take one more step. We still get the right answer as long as we do it correctly. It takes a little more time. Work smarter, not harder.
That's what Dad always told you.
It is. You guys know. All right. Anyone still need or have questions on 5?
Yes, sir.
I want you guys to try number 6. There's 3. What's going to change here when there's 3 of them?
Nothing.
You just have to make sure it's a common factor of all 3 of them. That's all. So raise your hand when you have or have questions. As we go over this GCF on this one, we'll say, okay, well, what number do they all have in common? Our biggest one, 5, right? Now, variables, do they all have an A in common?
Yes.
Yeah, to the power of 1, though, right?
Yep.
Okay, what about B's? Do they all have a B in common? No, okay. Hey, let me tell you a quick story, okay? So, the other day, I went to Walmart, and one of the things I wanted to pick up was Nutella, okay? I was out, needed more, because that stuff's amazing, okay? And I love me a peanut butter Nutella sandwich. Put the bread in the toaster, burn it out, and then put the peanut butter Nutella on it. It gets all warm, melted, delicious, okay? Anyway, and so I'm going to Walmart, trying to buy Nutella. It was one of the things I'm getting there, not only for that. They don't have it. Okay, they don't have it. Am I able to get it? No, I had to go somewhere else, okay? So here, did this first one have a B? No, if it doesn't have a B, even if the others do, if this one doesn't have a B, can I take a B from it? No, it doesn't have one. Just like when I go to the store and they don't have what I want, I can't get it because they didn't have it. I can't take what they don't have. Now, what I ended up doing is I went to Baker's down the street and they actually had a super sale on like a smaller size Nutella, like $1.50 off each. So you'll boil about 7 of those smaller sizes because you know what? They expire in December. Yeah, my wife and I are going to eat 7 of those by December for sure. So yeah, I'll buy 7 of them and save a lot of money. So I can basically make a story problem about myself. Mr. Costle buys 7
Probably buy
containers of Nutella.
Is this actually a true story?
Oh, I should have. What?
Is this a true story?
Yeah, this literally just happened on Tuesday.
No, I need to take a picture of it.
Bro, I haven't.
I have them all in my cupboard. Yeah. But and the nice thing is, okay, so Nutella, the big containers, they're actually harder to like get out because it gets all messy. Okay? Whereas like I think it's the way it's shaped. And anyway, and so I like the smaller containers just because of that, but the bigger containers are normally a better price value. Are those like slides
No, Mr. Costa.
on your socks? What's up?
Socks.
Five Below.
Yes.
They have like little ones this size.
Little tiny ones.
No, it's like A, B, C. The math side.
Oh. Oh, there's block letterings.
He just saw the
Yeah.
A.
Nutella things with the crackers in them.
Yeah, yeah.
They rip you off and put like half of Nutella in there. Like,
Yeah. Yeah, I never get those. I just get the straight Nutellas.
Never mind.
Probably.
Get it as haters.
Actually, they look more like James than me. All right.
Jane came home yesterday.
Oh, dope.
Well, for like 2 minutes.
All right. Hey, so 5A is what we can take out. So moral of the story, we can't take out what they don't have. So we couldn't take out a B. So as we take out a 5A is the slang, take out's the slang. Factor out a 5A is the proper term. What are we left with from the 25A squared? What does that become? 5A
Plus 2B squared.
plus 2B squared. So how's the B squared? That didn't change, okay?
Plus
Plus 3B.
Plus 3B, very good.
Ron got it.
Any questions on that? I go to Mr. Customize Me. Pleasure's all mine. All right, on 7, I'm just going to show you guys the answer because I feel pretty confident in that. What do we think is going to be different on 7? Does it have a minus sign? Other than that, not really anything, okay? So the GCF here is 3x, and you're left with x squared plus 2x minus 3. That'd be it. Okay. Now, yeah, if you want to. Oh, it is. All right, 8. Negative 2a squared plus 8a minus 4. What's slightly different about 8 than the others? There's a negative at the beginning. Yeah, we've had 7 and 4 have negatives, but this one has a negative at the beginning.
And that one does have a variable.
Okay?
It doesn't change the fact.
No, it would just be.
It would just be 2.
Okay?
Just because you'd make it a negative 1.
Okay. So what I'm actually going to have us do is say we are going to treat it slightly differently just because it's actually going to help us later in math if we do treat it differently. And so we're going to start off treating it differently now. So that way later we don't have to change something. We're just going to start doing it right away. Does that make sense? Because it's harder to change something after you've made a habit. But if you do that at the beginning, that way all along, it's going to be easier. So I'm going to factor out a negative 2. And so what's going to happen when I factor out a negative 2 of the negative 2a squared? It's going to turn into a positive what?
1.
A squared, 1a squared. What does positive 8a become though?
Minus 8A.
Negative 4. Very good. The sign changes. What does a negative 4 become?
Plus.
Positive 2. Now inside the parentheses, do these have anything in common?
The A squared.
No.
Do all 3 have anything in common? No. So I can't factor anything more out. And if I were to distribute, would I get what I started with? Yeah, and all those signs would change as I distribute in a negative, okay? So once again, the only reason we treated that differently is because we want that first term inside the parentheses to be positive because that'll actually help us later out this chapter even, okay? Yeah, Bailey.
Never mind.
Okay. Jill.
Wait, so if it's like a 3 equation right there, then if 2 have things like in common, we wouldn't do anything.
Correct. So like on like 6 even though these last 2 both have a B, we can't take out a B because the first one doesn't. On number 8 here, the first 2 have an A, last one doesn't, so we can't take out an A. The last 2 have a 2 in common, first one doesn't, can't take out a 2. Does that make sense? So they all have to have it. Whatever you're factoring out of, everything has to have it for it to do it. Yep, any other questions?
Do we have any don't do's?
We don't have any don't do's.
It's time for homework, I think.
Oh, you're so
I think so too. I think it's time for homework.